Assalamualaikum warahmatullahi wabarakatuh. Today my group, Jannah, Shazarid, Nadira and Musfirah will present Science Form 3 Chapter 9, Space Method. First, let's learn about structure of the sign. The structure of the sign consists of the parts such as convection zone, radiation zone, core, corona, chromosphere and photosphere. The corona, chromosphere and photosphere are the layers that form the sun's atmosphere. The facts about sun, such as the sun appears as a ball of glowing gases. The sun consists of hydrogen and helium. Without the sun's heat and light, the earth would be a lifeless ball of ice-coated rock. It radiates light, heat, and solar energy. Sunlight is for plants to grow. Sunlight also provides energy to warm the Earth's atmosphere. There are lots of phenomena that occur on the surface of the sun, such as granules, solar flares, sunspots, solar cycles, coronal mass ejections, solar wind, and prominences. First, let's look at granules, sunspots, and solar cycles. The photosphere in the sun's atmosphere is made up of granules that appears as a grainy structures. Granules is the upper part of the convection zone of the plasma. Granules also extremely hot with temperature as high as 5,800 degrees Celsius. The average diameter of a granule is 1,000 km. Next is sunspot. Sunspot is dark regions seen on the surface of the sun. The sunspot appear dark because its temperature is lower than surrounding area that are made up of granules. Sunspots are the location where the large eruptions in the photosphere. This phenomenon may last more than a week. Sunspots are phenomena that always exist in pairs or groups. Second is prominences. Prominences are huge loop or arched column of glowing gases over the sunspot. Prominences are very strong. They can throw out matter from the sun into space at speeds ranging from 600 km per second to 1,000 km per second. The prominences are able to reach heights of thousands of kilometers. Third is solar wind. Solar wind is particles in plasma such as electron, photon, and alpha particles that erupt from the sun to outer space travel together at high speed. The solar wind also carries the interplanetary magnetic field along with it. The speed of solar wind is supersonic with values ranging from 215 km per second to 715 km per second. However, the speed, temperature, and density of the solar wind change along the course of its movement. Number 4 is solar flares. Solar flares are a column of large amounts of charged gases erupting from the sun. Solar flares often occur near sunspots. Solar flares attain their maximum brightness level within a few seconds or minutes, and then become dim after few minutes or hours. Solar flares spout charged gas particles at high speeds into outer space. The charged particles often collide with atoms and molecules in Earth's atmosphere to produce a stunning light display in the sky known as aurora, which only occurs in the air space around Earth poles. Number 5 is coronal mass ejection. The coronal mass ejections are a huge cloud of plasma that erupts from the sun. The coronal mass ejections often occurs together with solar flares, which are huge and strong. The coronal mass ejections spout magnetic particles at high speeds into outer space and appears like an expanding cloud. The magnetic gas particles also react with atoms and molecules in Earth's atmosphere to produce aurora. Earth's magnetosphere and its importance. First, shape of Earth's magnetosphere. Compare and contrast the pattern of magnetic field lines between Earth's magnetic field and Earth's magnetosphere. Even though both of these patterns of magnetic field lines are not fixed, the pattern of Earth's magnetic field lines change slightly while the pattern of the magnetic field lines in the magnetosphere change a lot, based on the interaction between solar wind and Earth's magnetic field. Definition of Earth's magnetosphere. Earth's magnetosphere is defined as a region in outer space surrounding Earth, where the magnetic field in Earth's magnetosphere is a combination of Earth's magnetic field as the prime magnetic field, and the magnetic field in the region is outer space.
Okay, next for the formation of Earth magnetosphere. How the Earth magnetosphere is formed? Okay, magnetosphere is formed by the interaction between the magnetic field brought by the solar wind and the Earth magnetic field. As the number and energy of particles brought by the solar wind change, the shape of the magnetosphere also change. So as we know, solar wind, it will bring particles in plasma such as electrons, protons and alpha particles to Earth. Okay, basically it shows that the size of the magnetosphere is based on the number of particles in the solar wind. So let's say if the solar wind brought many particles, more particles, so the shape of the magnetosphere will become bigger. This magnetosphere can protect Earth from the adverse effect from harmful particles in solar wind. Okay, so for the importance of Earth magnetosphere. Okay, the importance of Earth magnetosphere is to protect Earth from the adverse effect caused by dangerous particles from the sun or other bodies in the universe. The function of the magnetosphere is as a biological shield, shield to protect life on Earth from the adverse effect of solar wind. Okay, the magnetosphere also blocks charged particles such as electrons, protons and alpha particles in the solar wind from reaching Earth. It is because excessive numbers of charged particles in Earth's atmosphere will disrupt telecommunication, navigation system, and electric power line. So basically, the excessive number of particles will cause harm to the life on Earth. The magnetosphere can reduce the pressure exerted by the solar wind on Earth's atmosphere. Okay, next we go to 9.2 space weather. In this subtopic, we will learn about two things: space weather and the effect of the space weather on Earth. Okay, space weather can occur on the surface of the sun, such as solar flares, prominences, sunspot, and coronal mass ejection. And also, it can occur in space, such as solar wind, solar radiation storm, and geomagnetic storm. Okay, next, interpretation of data on space weather. Data on space weather is used or analyzed to forecast when coronal mass ejection occur in sun. And also, it can determine the reasons for the occurrence of solar flares and coronal mass ejection on the surface of the sun.
That's all from us. Thank you.